Hello everyone, welcome to another session of Learning from Home. Today we are going to learn about acids and bases. Acids first. There are three types of strong acids we need to know. The first one is the hydrochloric acid with the chemical formula of HCl. The second one is the sulfuric acid with the chemical formula of H2SO4. The third strong acid is the nitric acid, chemical formula HNO3. Strong acids dissociate completely in water to give you lots and lots of hydrogen ions. It is the hydrogen ion that is responsible for the acid properties. For example, hydrogen chloride is a gas. When it dissolves in water, it will dissociate to give you hydrogen ions and chloride ions. The hydrogen ions are responsible for acid properties. Because of the 100% complete dissociation, you end up with many hydrogen ions that gives rise to very strong acid. Similarly, the sulfuric acid will completely dissociate in water to give you many hydrogen ions that gives rise to a very strong acid. And similarly, the nitric acid will also dissociate completely to give you lots and lots of hydrogen ions, giving rise to very strong acid properties. Now, the weak acids are normally the organic acids or the acids that we consume, that we take into our body. Example would be the citric acid, which is commonly found in oranges or lemons. The ethanoic acid is commonly found in the vinegar. Malic acid is found in apples. You also have the tannic acid, which is found in tea. The tartaric acid that is found in grapes. And finally, lactic acid, which is found in milk or in our muscles when our body undergoes anaerobic respiration. These are the acid properties. First, all acids have a sour taste. So anything that's sourish is an acid. Acids can conduct electricity provided they are dissolved in water. Pure acids cannot conduct electricity. It is the water that dissociates the acid into individual ions. It is the ions that conduct electricity. So pure hydrogen chloride gas cannot conduct electricity. But when hydrogen chloride is bubbled into water and dissolved in water, the water will completely dissociate the hydrogen chloride into H plus and Cl minus ions. Then it can conduct electricity. Concentrated acids are corrosive and burns your skin. Acids turn blue litmus paper red. Acids can react with metals, metal carbonates, and alkalis or bases. Let's look at the acid reaction with metals more closely. When acids react with metals, they form salts and hydrogen gas. Acid plus metal gives you salt and hydrogen gas. There are three examples to remember. When a metal reacts with sulfuric acid, you will get a sulfate salt. When a metal reacts with nitric acid, you get a nitrate salt. When a metal reacts with hydrochloric acid, you will end up with a chloride salt. So a sulfate salt comes from sulfuric acid. A nitrate salt comes from nitric acid. A chloride salt comes from hydrochloric acid. The metal will form the first name of the salt. So if it's a magnesium metal, you'll get a magnesium salt. If it's a sodium metal, you'll get a sodium salt. If it's a potassium metal, you'll get a potassium salt. The other product of metal plus acid reaction is hydrogen gas. How do we test for hydrogen gas? We can use a lighted splint. Hydrogen gas will extinguish the lighted splint with a pop sound. Second, let's look at the reaction of acids with carbonates. Acids react with carbonates to give you salt and water and carbon dioxide. In the same way, if sulfuric acid is used, you will get a sulfate salt. If nitric acid is used, you will get a nitrate salt. If hydrochloric acid is used, you will get a chloride salt. And if the metal is lithium, then the salt begins with lithium. If the metal used is calcium, the salt name, first name is calcium. If zinc metal is used, the salt first name is zinc. The other two products being carbon dioxide and water. Carbon dioxide and water, carbon dioxide and water. This has to be committed to memory. How do we test for carbon dioxide? We can use the lime water to test for presence of carbon dioxide. Carbon dioxide will turn lime water chalky or milky, or we say that white precipitate is formed when carbon dioxide is bubbled into lime water. Finally, let's look at acid reaction with alkalis. Acids react with alkalis to give you salt and water only, and this reaction is called the neutralization reaction. Right? Acid plus alkali gives you salt and water. Again, if it is a sulfuric acid, you will get a sulfate salt. If nitric acid is used, you get nitrate salt. If hydrochloric acid is used, you get a chloride salt. And if sodium hydroxide is used, you get a sodium metal. Potassium hydroxide is used, you get potassium as the first name of the salt. If lithium hydroxide is used, you get lithium as the first name of the salt. And the other product is water, and this has to be committed to memory. At this point in time, it is important to understand what is an alkali. An alkali is a metal oxide or a metal hydroxide. So sodium is a metal. So sodium hydroxide is a metal hydroxide. It is an alkali. Potassium hydroxide is a metal hydroxide. It's an alkali. Lithium hydroxide is a metal hydroxide. It is an alkali. Now, the universal indicator gives different colors under different acid or alkali conditions. The universal indicator will give a red color in acid conditions. It will give a blue color or violet color in alkaline conditions. And if it's neutral, it will show a green color. Alkalis are defined as anything that dissolves in water to give you hydroxide ions. Alkalis neutralize acids to form a salt and a water. The reason is because acids produce H+ ions. Alkalis produce OH- ions in solution. When these two ions come into contact with each other, they combine to give you water, which is a neutral product. Hence, acids neutralize an alkali to give you the neutral water. Alkalis have these properties. They are soapy in texture, they turn red litmus paper blue, they can conduct electricity when dissolved in water, and they can be corrosive when concentrated. Because alkalis are soapy, you'll find them used in toothpaste, soap, detergents, and so on and so forth. It is the alkaline property of the toothpaste that will neutralize the acids in the teeth caused by the decaying action of bacteria. And this will help to preserve the teeth because bacterial acid can react with the carbonate in the teeth to form salt and water, and when that happens, the carbonate teeth decays and you get a tooth decay. At this point, it is also good to understand the word bases. Generally, bases and alkalis have the same properties. Essentially, an alkali can be considered as a base that can be dissolved. So an alkali is essentially a soluble base. It is important to understand the basic definition of a base. The base is defined as anything that will neutralize an acid to give you a salt and water only. But in practice, what exactly is a base? A base is either a metal oxide or a metal hydroxide. This is important. So for example, CuOH2, copper hydroxide, it is a base. CuO, copper oxide, is also a base. Any metal oxide or metal hydroxide are bases. The pH scale. The pH scale is a scale that shows how acidic or how alkaline or how neutral a solution is. pH 0 is considered very acidic. pH 1 is also very acidic. pH 14 on the other end and pH 13 are highly alkaline. pH 7 is exactly neutral. pH 6 is slightly acidic. pH 8 is slightly alkaline. The pH of a solution can be determined using an indicator or a pH meter. Indicator. The indicator shows different colors in different pH solutions. The universal indicator can show different colors corresponding to different pH levels. It allows one to determine the strength of the acid and the strength of the alkali. So for a universal indicator, pH of 0 to 2 will be shown as red, 3 to 4 will be shown as orange, 4 to 6 will be shown as yellow, 7 will be shown as green, 8 to 11 will be shown as blue, and 12 to 14 will be shown as violet. Now notice this sequence is exactly the sequence of the colors of light. White light comprises of 7 colors: red, orange, yellow, green, blue, indigo, and violet. So apart from indigo, the rest of the colors correspond to this same sequence. The universal indicator can tell the strength of the acid because if it's red, it's a strong acid, and if it's 4 to 6, it's a weak acid. Similarly, a color of violet shows it is a strong alkali or strong base. Color of blue shows it is possibly a weak alkali. Now there are other indicators in our lab, namely the litmus, the phenolphthalein, and the methyl orange. We only need to focus on the litmus. The litmus is red under acidic conditions and blue under alkaline conditions. Under neutral conditions, the litmus will not change color. So if you have a red litmus and you put it in a neutral solution, it will not change color, it will remain red. If you put a red litmus into an acidic solution, it will also remain red because litmus turns red in acid conditions. Hence, when you put a litmus in a solution and it remains red, then it can be either the solution is neutral or the solution is acidic. You cannot conclude that the solution will definitely be acidic. Similarly, if you put a blue litmus into a solution and it remains blue, then there are two possibilities. Either the solution is neutral or the solution is alkaline. So when you put a litmus into a solution and it remains blue, you can't conclude that it is alkaline. It can also be neutral. Other indicators would be the phenolphthalein, which you don't have to remember, but when pH is more than 9, it will be pink in color. When pH is less than 9, it will be colorless. For the methyl orange, when the pH is less than about 4, it will be red in color. When the pH is greater than 4, it will be yellow in color. Finally, let's look at an example. What we have here is two indicators, methyl orange and methyl red. And then we have four solutions, P to Q, or rather P to S, with different pH values. Now, which solution will appear red under both indicators? So to be red under both indicators, so let's shade out the red parts. This is red, and this is also red. So what are the pHs where both methyl orange and methyl red are red? Answer is 2 to 3. For pHs 2 and 3, both indicators are red. That will mean P and Q. So that is the answer.